Right, so we want to figure out when this rocket will hit the ground. Um, Asking me when the rocket will hit the ground is the same thing as asking me when it'll be 0 meters high. So in order to figure out when it'll be 0 meters high, we can replace h with 0. So if I plug 0 in for h, I'll end up getting 0 equals negative 4.9 t squared plus 43.4 t plus 6.3. Right, so what we're doing is we're trying to figure out when the rocket will be 0 meters high, which is equivalent to determining when it will hit the ground. Now this is a quadratic equation due to the presence of the t squared. When I'm solving a quadratic equation with a trinomial like this, I prefer to have the leading term positive. So if we move all the terms that are on the right to the left-hand side of the equation, or look at it as multiplying both sides by -1, I can rewrite the equation as positive 4.9 t squared minus 43.4 t minus 6.3 equals 0. So I multiplied both sides of the equation by -1. That way my leading term is positive. Now to solve this equation, we actually have two choices. We could attempt to solve it by factoring, or we could use the quadratic formula. Sometimes when you have messy decimals like this, it's often preferred just to go straight to the quadratic formula. But when we have decimals, we can make an attempt at factoring. So if I encounter this equation, the first thing I would attempt to do is divide across the board by 4.9. That would make the leading coefficient 1. But when we divide the next term, the 43.4 by 4.9, we'll see that it doesn't come out to a nice number, which prompts me to back up. I don't want to divide across the board by 4.9. Sometimes though, maybe we can divide by another number and it'll turn these decimals into nice integers. But it's not easily seen sometimes what we'll divide by. It turns out that if we divide across the board by the number 0.7, if I divide every term by 0.7, I'll end up getting 7t squared. So 4.9 divided by 0.7 is 7, and then 43.4 divided by 0.7 is 62, so we have 62t, and finally the 6.3 divided by 0.7 is 0.9. Notice that after dividing by 0.7, the numbers in this equation are much nicer. There's no more decimals. But a great question is, where did that 0.7 come from? Well, it's notice that when we think about 4.9, or the number 49, if we think about a number that goes into 49 evenly, 7 is probably pops up in many people's minds. So, and it turns out 0.7 goes into all three of the numbers evenly. If the leading coefficient had been, say, 6.4, then I think trying to divide by 0.8 would have been an excellent choice. Or if the leading term had been 2.5 t squared, then trying to divide by 0.5 would have been an excellent choice. All right, so I'm going to continue this equation, but when I'm done, I'm going to also look at it via the quadratic formula. We don't have to solve this by factoring. What if we didn't divide by 0.7? What if we didn't think about dividing by 0.7? So again, it is a good question where that 0.7 comes from, and if we think about the number 49, note 7 goes into 49, so with 4.9, 0.7 is an excellent choice to attempt to divide by. Again, if divided by 0.7 didn't make all the numbers come out so nice, that would probably further prompt me to use the quadratic formula instead. All right, so let's finish this. So I'm going to factor it. The leading term is a 7t squared, so we'll have 7t and 1t. And the two numbers in the back need to multiply to a -9, but the 3's won't work because I'll never get that middle term, the negative 62 in the middle. But if I put -9 here and 1 here, this is the correct factorization. If we FOIL these two binomials, we'll see that we get back to the previous trinomial. And so if I proceed to set each of these equal to 0, I get t equals 9 and t equals negative 1/7. Now t represents a time. In seconds, it looks like if I go back up here. T is in seconds, it says up here. So since t is a time, we consider the negative solution extraneous, and so the answer to the problem is 9. The rocket will hit the ground in 9 seconds. Okay, but again, what if we didn't think about dividing by 0.7? You know, often when we have decimals, maybe we wanted to just go straight to the quadratic formula. So if I start with this right here, in order to use the quadratic formula, I need to identify the values of a, b, and c. And so a is the number in front of the square term, so a is 4.9. B is the coefficient of the t term, so b is negative 43.4. And c is negative 6.3. And so now I'm going to insert these numbers into the quadratic formula, which is negative b plus or minus square root b squared minus 4ac all divided by 2a. So we have negative b. Since b is negative, well, here I'll go ahead and write it. Negative b, that'd be negative 43.4 plus minus the square root of b squared minus 4 times a times c, and that's all divided by 2 times a, 2 times 4.9. And then now we're going to simplify, so we have positive 43.4 plus or minus the square root. If we take negative 43.4 squared, we square that, and then we add the product of 4 times 4.9 is 6.3. It'd be adding that product because of the two negatives, the negative 4 and the negative 6.3. So if we simplify what's inside the square root, that's called the discriminant, the b squared minus 4ac, with the help of a calculator, we'll see that we get 2007.04. And 2 times 4.9 on the bottom is 9.8. So we have t equals 43.4. The square root of 2007.04 with the help of a calculator, I got 44.8. Okay, here's where we can break up the plus and minus. So we have t equals 43.4 minus, excuse me, minus 44.8 over 9.8. And we also have t equals 43.4 plus 44.8 over 9.8. Now on the left, 43.4 minus 44.8, that would come out negative. So this is the extraneous solution. That would end up giving us the negative 1/7. But on the right-hand side, if we take 43.4 and add 44.8 and divide that by 9.8, we'll come out with the answer 9. And so once again, 9 is the answer. And so I've solved this equation using two different methods. On the left, I solved it using factoring. Oops, that's kind of messy. And on the right, I used the quadratic formula.